So good morning to everybody. Today I will start with k nearest neighborhood method. K nearest neighborhood method. So let us see what is the logic of this. Let us see what is the logic of this method. So suppose this is your y-axis. Suppose this is your x-axis. X-axis and y-axis. All right. Now, if you are not getting clear, is it clear now? Is it clear to you? Okay, this is your x-axis and y-axis. Now suppose we have two features, x and y, and suppose we plot these points. Suppose we plot these points. Say for example, suppose this is the points I have plotted, and I can plot few more. So suppose this is what the data points I have plotted. I will plot few more. And suppose my data is this. This is class A data. This is class A data. Now let me plot class B data, and that class B data is say like this. Yes. Yes. Suppose this is class B data. Suppose this is class B data. So class B data. And now suppose I have some other observation that I want to classify. And suppose this observation is this one. The observation that I want to classify is suppose this. And suppose it is plotted here. This is what the situation is. So see, this is my present situation. I have two features, one feature plotted on x-axis, another feature plotted on y-axis, and two sets of data, two classes of data are marked as blue color and red color. So there are two data sets. One blue colored data, another one is red colored data. That means this is what I know. This is my historical data. These are the instances I know. And suppose I have a one observation that I want to classify, whether it is of red type or whether it is of blue type, whether it belongs to class A or whether it belongs to class B. That is what I want to classify. We have many other methods, SVM, Bayesian, logistic, linear discriminant, and today we are studying about k nearest neighborhood. What we will do is, I will decide k equal to 3. I will decide k equal to 5. I will decide k equal to 7. I will decide k equal to 9, 11, 13, 15, 16, 17, 19. I will decide k as a odd number. I will decide k as a odd number. And from this point, I will find the all distances. Distance of the point that I want to classify with other all points. So suppose this distance I will classify. I will find out these distances. Suppose this distance I will find out. 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 So I will find out the distance of this point, the point which I want to classify. I will find the distance of this point from all possible points. From all possible points. From all possible points. Right? I will find the distance from all possible points. And then the logic is very simple. The logic is by majority. The logic is based on the rule of majority. Suppose this. I will find out all such distances. So try to understand this. I will find out all these distances. So what I will get is this. I will get this. Let me write. I will show you a table. I will get like this. See here I have first observation x1, I have x2, I have x3, and like this I have xn observation. And so this is my observation number, and here distance. So this is d1, d2, d3, like this, dn. What is this di? Let me write that di. What is this di? Di equal to, yes, di equal to, it is distance between xi, distance between xi and what? say observation, say say unclassified observation, this green, I will call it as unclassified observation. This is, say, your observation U. This is, say, your observation U. So you are finding the distance of each observation from unclassified observation U. And now I will decide k equal to, decide about k, decide k, usually odd. I will tell you the reason of odd also. Decide k, usually odd. Let me, for example, take k equal to 3. Let us take, for example, k equal to 3. For example, say k equal to 3. The same story will work for other k also. Among these distances, I will find the 3 minimum distances. I will find the 3 minimum distances. I will find 3 minimum distances. And then you see here, okay. Okay. So let me draw a circle with no field, and I will come here. Okay. So let me make it dark. Okay. Okay. Can you see this? Yes, I think, hope you can see this. Yes. K equal to 3. Now you see around this unclassified observation, out of 3 observations, all the 3 observations are of blue type, and therefore this observation is also classified as blue type observation, means a class A type. If my K is even, and if one observation, if my K is even, and suppose I take K equal to 2, then see what is the problem. If out of 2, one observation is blue, another observation is red, then there is a dilemma, then there is a confusion where I should classify it. But if K equal to 3, there is no such dilemma. Such equality is not possible. And therefore, usually K is taken as odd. Now, if I take K equal to, say, 5, see what happens. If I take K equal to 5, what happens? So if K equal to 5 means this will get extended. The circle will become more, and there is a possibility of more observation in the circle. Now, if you see this with K equal to 5, there are 4 observations of blue type and 1 observation is of red type. That means 80% observations are of blue type only 20% observations are of red type, and so majority carries. Your unclassified observation is also blue type, and so it is classified as blue type observation. If I take k equal to 7, let me take k equal to 7 also, and see what happens. Again, this will be get extended. This circle will get expanded. And what will happen to this circle is, let us see this. This is going to happen with the circle, right? And if you see now, you will find that out of 7, 3 observations are of red type and 4 observations are of blue type. So again, majority carries, and unclassified observation will belongs to blue type. If I take k equal to say 9, see what happens. K equal to 9. See, with k equal to 9, situation is changed. Out of 9, 5 observations are of red type, 4 observations are of blue type. And therefore, your observation is classified as red type. So the concentration of a class of observation will decide where your unclassified observation will lie. That is the idea. So it is a purely mathematical approach. It is based on mathematical concept. There is no probability as such. There is no statistics as such. There is no statistical distribution as such. There is no error as such. And so it is a purely mathematical approach, like SVM, that support vector machine. Now I will apply this to iris premium data, and we will see how it works there. What is the output of that data? So let me save this and stop this screen. I will add another screen that is of Excel. Okay. Yes. So this is my iris data. This is my iris data with 150 observations. And suppose we have here some other data, say 5.3, 2.3, 4. Sorry, 3.5, 1.23, and 0.19. This is one observation. Then 5.6, 3.9, 1.56, 0.25. This is another observation. Say 5.9, 3.1, 1.85, 0.35. Suppose these are the 3 observations, and I don't know it's a class. I don't know it's a class. I don't know it's a class. So I want to make the classification. So how to do this? I have 50 observations from iris setosa, 50 observations from iris virginica, and 50 observations from iris versicolor. So with the help of this 150 set of data, I will decide the class of these 3 observations. So let us come to Excel machine learning, come to k nearest neighbors, and see here. See here, you have to enter y. What is y? It is a qualitative data. It is given that qualitative. There is a possibility of quantitative also, but default they have given qualitative. So qualitative is what in our historical data? Class. So I will enter this data class. So this is my output variable. This is my response variable. Quantitative data, explanatory variable, X variables. That is my sepal length, sepal width, petal length, petal width. So this is my data. Okay, this is my data. Now let us come to the prediction. Let us see the prediction. I want to predict which variables here. I want to predict these three observations. This is what my predicted data is. And let us say okay. And let us say okay, this is k nearest neighbor. This is k nearest neighbor. And see here, number of neighbors they have taken as 5. Number of neighbors they have taken as 5. So this observation and this classification is based on k equal to 5. Summary statistics is given here. Sepal length, sepal length. I think I should not talk about this because it is already we have done. This is the summary statistics of predicted prediction set. And here we have to predict 3 observations. See here, observation 1, predicted class is iris setosa. Predicted class is again setosa. Predicted class is again setosa. This is with k equal to 5. Now, is there any chance for changing k equal to? And let us see option. Let us see option. In the option also there is no change for, there is no scope for changing this. Now in Euclidean distance, see in distances, there are various possibilities. If I try with Minkowski distance, see what happens. With Minkowski distance, the same classification is there with Minkowski distance. Okay, with Minkowski distance, same classification is there. Right. Now, you can change the Minkowski distance to, say for example, Manhattan distance and see what happens. Same classification is there, right? If you take, see the output is descriptive statistics, results by class and results by objects. Options is I have already discussed. Let us see observations to track all observations. Yes. See, this is very important thing you can understand. This is your prediction observation 1. And here k equal to 5. So you will see that these 5 data sets, who are the 5 neighbors? These are the 4 neighbors. These are the 5 neighbors. Observation number 37, observation number 28, observation number 29, observation number 1, and observation number 41. These are the neighbors. And if you see the distances between them, 0.26, 0.36, 0.36, 0.36, 0.36, 0.36, these are the neighbors. And based on these neighbors, all these data sets are belonging to Setosa, your prediction observation also fall in Setosa. The same is worked with observation number 22nd. Same is worked with observation number 3rd. I think we can change here distance. Let us see mean square distance and see what happens with this. See this. Okay, I think we should not go for this distance. We can go for our regular Euclidean distance. We can go for our Euclidean distance. And now see what happens with this Euclidean distance. See this. These are the distances. These are the 5 observations. For example, suppose we can put here 3.5, then say 4.2, 2.1, and say 0.78. Okay, 0.8. Let us see this. And I want to classify this. Let us see what happens with this new observation. Okay. In prediction, I will put it 5 and see what happens. So see, size of the prediction set becomes 4. Still all observation belongs to Setosa. Still all observations belongs to Setosa. Let me put it, this is 7.5 and let's see what happens. Still all observation belongs to Setosa. Right? Let me take something different here and say 2.1 and see what happens with this. Yes, now you will see the change here. Observation 4 belongs to versicolor. And if you see this 4th one, see this 4th one. See this 4th one. 139th observation is from versicolor. 68th observation is from versicolor. 97th observation is from versicolor. 30th observation is from Setosa. 16th observation is from Setosa. But out of 5, 3 observations are versicolor, 2 are of Setosa. So majority carries, it belongs to versicolor. Right? So this is k nearest neighborhood method. This is k nearest neighborhood method. So I have shown you my slide. This how to classify an unknown observation, and we have done this in our iris Setosa data. Correct? You have to take k equal to 3, k equal to 5, k equal to 7, k equal to 9, and in the default Excel stat it is k equal to 5. Now you can do with R, you can do with Python by changing k, by changing distances, and see what happens. Okay, so this is k nearest neighborhood method. So with this, I will stop for today.